Labą dieną. Malonu Jūs matyti mūsų kartu su IBM organizuojamam šiandien seminare, kur pakalbėsim apie hibridinį sprendimą diskų masyvams. Kitaip tariant, šiaip žodis hibridinis paskutiniu metu tapo labai populiarus. Mes turim hibridinį darbo stilių. Tai va šiandien nusprendėm palaikyti šią temą ir pakalbėti apie hibridinį storage. Bartošas šiandien pasitengs paaiškinti, kas iš tikrųjų yra tas hybrid cloud storage'as ir gyvai parodys, kaip iš tikrųjų galima, turint pas save duomenų centre IBM diskų masyvus, perkelti duomenis į debesis, kaip tai galima padaryti ir saugiai, ir kaip tokiu būdu užtikrinti duomenų saugumą ir jų prieinamumą. Keletas organizacinių dalykų, tai jeigu turėsit kažkokiu tai seminaro metu klausimų arba kas nors bus neaišku, tai dešiniajame apatiniam kampe yra langelis, kur tos klausimus galima rašyti ir mes juos stebėsim, kai kažkokie tai atsiras iš karto Bartošui ir perduosim. Tai tiek pradžiai. Malonaus klausymosi ir Bartosz, you're welcome. You can start your presentation.
Hello, good morning, everybody. Actually, good afternoon even. Okay, just tell me whether my presentation is visible. Just give me a second.
Not yet.
Mm-hmm. What about now?
Yes, we can see a black swan.
That's great. Okay, so let me start our workshop from a bit different way that I used to be starting. I will share with you a theory of the black swan event. So until the 17th century, people believed that there were only existing white swans, and there was even an ancient saying that presumed black swan didn't exist, like something could not just happen because it's not possible. However, in the time when the planet colonization was made, when Australia was also discovered, some of the explorers found and actually even proved existence of the black swan. I know it's hard to believe right now. I mean, it sounds ridiculous, but at this time it was a huge event which many people could not just simply believe. Okay, so what is the concept of the black swan event? It is a kind of metaphor that describes an unpredictable event that comes as a surprise. Of course, for some of us, it's not, but for the better part of people, it is a surprise and has a great effect. First of all, a great effect, and the second, consequence. We can describe many things as an example of the black swans. Sometimes positive, like invention of the internet or penicillin, but sometimes also as a negative ones, like economical crisis on the world markets, or unexpected wars, which caused a great number of casualties. Some of us are also understood. We are also understood sometimes this COVID-19 as a kind of black swan, but the situation has been previously made, right? Something like 100 years ago, there was also a great flu which cost millions of casualties and dead people. Okay, so how can we protect against happening of the black swan in terms of our IT infrastructure? My name is Bartosz Pizań, and I'm client technical specialist at IBM. And I'm going to show you how hybrid cloud infrastructure can prevent on such a negative events from happening. So what can we do to cut off all the risk, maybe not all, but let's say that 99% of the risk of disaster, of data center disaster and outage, which always costs a lot of money and effort. But before, let's see how Black Swan even can look like from my different clients' perspective, because in every client, it looks a little bit different. They are experiencing different just events, which cost a lot of money and effort. Okay, so the first example is a typical. I mean, typical because we have heard, probably everybody have heard a lot of things about some data center burn. I mean, the fire which caused getting burned all the data center. So for clients, everybody heard about it, but for everybody, it's always unexpected because, come on, my data center is on such a high level that it could not get burned. But sometimes it does get fired and completely destroyed. So a couple months ago, one of clients' data center burned. Fortunately, he was prepared for this situation. I mean, we were prepared as an IBM because he was having our storage and servers, and he was prepared also for the situation. Almost all systems were mirrored to the second disease. So the core system, banking system, were mirrored, so nothing happened. Thanks to this synchronous replication, which he used, it was in our case IBM HyperSwap, which is present in our storage system. He was able to automatically switch to auxiliary data center. But what has left and our client was not able to recover was the test and development environment. For some of us, it's only test and development systems and environment made for teams of programmers, so we don't have to protect them because it's not so necessary and it's not core business value. However, those systems were used by hundreds of developers who were working on maintenance and new versions of banking applications and also services. And just imagine a situation that for a week, they were not able to work because they were left without working tool, which was those clones of the working volumes, of the databases, of the systems, of virtual desktop, etc. Because client did not choose to make at least snapshots or clones of test environments. So we are not talking about a full mirrored situation, but a little backup, which is named here as in a storage level as a snapshots or the clones, and it cost millions of indirect loss. Why? Because they still had to pay to their employees, to those developers who were programming for them, but employees did have no possibility to work for this time. So that's the first situation which we understood as a black swan in client's data center. And the second situation, let's get to this unbelievable example, which I heard from a couple of my friends. In previous week, you may heard some news about some services outage. And just to mention some of them, like Financial Times, like Reddit, The Guardian, Twitch, HBO, Spotify, those are well-known brands. I mean, of course, not all of those were listed here, so we may expect that many others were also damaged. So all those sites, also all those enterprises were unreachable for at least 4 hours. And here's the question: why? It seems that one AWS, which is this Amazon Cloud, availability zone located in Central Europe, so let's say that in Germany, was down. According to rolling disaster scenario, one outage caused another. So after a couple of failures, they have faced this great unavailability of their working system. So we may ask how much money all those companies and government also agencies have lost. Well, in my opinion, it's extremely hard to count because so many systems were down that counting the direct and also those indirect loss will be probably spread over the time for many months. So maybe after a couple of months, we'll realize how much money they have lost, like overall, all of those companies which were not available. So it's not the very first time when cloud providers have problems with availability. And I'm not only talking about this AWS, it also can appear on Microsoft Azure, Google Cloud, or also IBM Cloud, which I'm a part of. So everybody experienced it, or rather the clients experience it, because some of them are completely dependent on cloud provider service. And when I'm showing those examples, I'm not talking about this cloud pros and cons, because it's a great discussion about this pros and cons of the cloud. I just want to note that safety of our services in cloud might not be as high as we assume. It might be as not so reliable as we previously thought. And I'm also sure that this day, not only for cloud provider, but especially for this Spotify, for this HBO, CNN, etc., stuff was a black swan event, which they just did not completely expect. Okay, so coming back a little bit to the topic of safety and infrastructure. So how can we prevent it? What can we do to make our whole infrastructure a little bit more reliable and a way more safer? So in my opinion, the answer is a hybrid cloud approach, which is partially based on traditional on-premise environment hosted in our location. When the second part of our production system, on our test development system, etc., are hosted in one of cloud vendor availability zone. Just not to put everything in one cloud data center, but they do have also possibilities of this availability zone, which, as we can see, may also get down. So from the one hand, in this hybrid cloud infrastructure, we are receiving independence in case of public cloud outage, just like it happened in the AWS case. And from the other hand, we are protected against our own data center fail with failover straight to the cloud. So we may also automatize it. We may create this remote mirror, synchronous or asynchronous replication. So in my opinion, it's extremely important. And thanks to the software, which is present on the flash system storage, previously it was known as a Storewise, but the firmware, the software, which is present on our storage is IBM Spectrum Virtualize, with possibilities to having the clones straight to cloud and creating this hybrid cloud approach. And additional software, which is IBM Storage Insights, we may easily deploy and manage hybrid cloud infrastructure, which is in most cases suited for our needs, because as everybody know, cloud is giving us a great opportunities in terms of scalability, which I'm going to describe also a little bit later. Okay, so how can we do it? What can we do with those features? How can we protect our data center against these failures? And how to build this, how to implement, not only build, but also implement this hybrid cloud approach. Okay, so first and the simplest way of building this hybrid cloud approach is the function which is built in our system storage in a Spectrum Virtualize software, and this is transparent cloud tiering, known better as just a simple TCT. So it's a very simple feature of making snapshots, I mean incremental snapshots with relations or clones without any relation of storage volumes and sending them straight to the cloud. So let's say that we are using here S3 protocol to send copies of the volumes to separated, in this case, AWS bucket. So we have three good and very easy to understand examples of this TCT usage. So the first one is this case of the backup. we are just making a copy of our volume and sending it straight to cloud. So storing copies in the cloud, recover to the same or a different volume a little bit later in case of having a need of recovering. And this is the function which I'm going to show you a little bit later in a practice. So we are going to implement this connection of our system, and then we will make a copy of volume, send it straight to cloud, and after that we are going to just simply recover it. So that's the first case. The second case is archive. So we may store our copies of volumes in the cloud, so we do the same. Just simply make a copy of the volume, send it to cloud, and also delete it from our primary site, because let's say that we have some versioning of our test or development environment. So it will help us to keep the copies and to create this active archive with just the archive. In case of having a need of making a restore, we may also easily do it. And the last thing which I mentioned here is the possibility of having this transfer. So let's say that we do have completely separated environments. So the cloud might be something like reliable third side between those copies, kind of middleman, because we may just create a copy of the volume, send it straight to the cloud, and straight from cloud having a restore to another production or different or having a different purpose environment. So it's nothing easier. Okay, I think it's pretty understandable. So do we have any questions right now for a moment?
No, so far now, no, we can continue.
Okay. That's great. So right now we do have this transparent cloud tiering showtime. So let me just share my screen. Okay. Is it visible right now? I mean, the scenario and a couple of more informations.
Yes.
Okay. That's great. I have recorded a video of this. I'll be stopping and also making some assumptions, comments, and all these things. So on the firstly, we have this cyber resiliency use case. So we do have this on-prem data center with some virtual machines and source volume. And from the on-prem configuration, so yeah, just what I said, Linux server connected to a storage. It's something like, if I remember, it was a Storewise V7000. Right now it's Flash System 7200. So we may just have some changes in the naming, but the core things like a Spectrum Virtualize code is completely the same. Yeah, that's right. So we do have Storewise V7000. After that, we are logging in. I hope that you are familiar with this Spectrum Virtualize GUI. Which is present on every of our storage system from the Flash system or Storewise family. But if not, then it will be nothing easier just to understand, because it's a very simple graphical user interface, and we will see our system from the monitoring. After that, we are checking how many volumes do we have and some more informations. Okay, so now let's check some possibilities of connecting it to AWS buckets. So that would be good case for having this hybrid cloud, not only in terms of having a backup, but also in case of ransomware, because the copy of volume which we are going to send to AWS will be completely separated from our production site. So we may do this copy with relation, without relation. In case of having this ransomware attack, we may easily restore from the cloud. Okay. So first of all, we have to create some bucket and user. This is AWS interface. So if you're not familiar, also I encourage you to check what is this AWS, because I think that is the most popular storage, cloud provider worldwide. So I just simply get here by to adding a user, to adding a user group, and to have this possibility of connecting to our cloud. So we have here access key ID and secret access key, because it's required when we'll be already checking and making connection between our storage system and AWS bucket, where we will be putting this copy of the volume. It will be necessary to set this connection between our systems. Okay, so yeah, here you got this secret key. We have to copy all of these things. So the best way is just to download it, or just copy from the AWS HTTPS perspectives on the web browser. And right now in the settings, we are coming back to our storage system, which is Storewise V7000. On the settings, we may check this possibility of transparent cloud tiering. So first of all, before we can send our volumes, we have to set this connection between cloud and on-prem environment, and it's named as a transparent cloud tiering, which I mentioned previously. After that, we have to enable cloud connection, and of course, I understand the risk and want to continue. Straight after, we are enabling this cloud connection with choosing the proper provider for our cloud. And in this case, I'm using this Amazon S3. Yeah, and those are the details which I have, which we have put previously. Which we have seen previously on AWS. So the access key ID and the secret access key. Also, we have copied that. Then we are making this bucket prefix, which will be visible on our system. Also, we may also enable encryption, not in this case because it's not encrypted machine, but yeah, it's also doable. And another thing is the bandwidth. You may also set a bandwidth, but in this case, there is no limits. There is no QoS for enabling this cloud volume. Okay, very useful thing. Everything which we are making on our storage system is running by commands. So in case that we are great enthusiasts of command line, we may easily learn all those commands which are visible after running every task. It will be visible also on the screen. Okay, and the last one, which is the summary. We are seeing here all the details which we put previously. So right now we can finish, and our connection to Amazon S3 bucket, it's already set. Okay, let's get to another thing. How transparent cloud tiering can help to implement a cyber resiliency solution. And okay, here we have this versioning, which is keeping all the versions of our volume. Is very important in case of this ransomware use case. And the second thing, which is also important in this use case, is this isolation. So this bucket is completely isolated from our on-prem instance of our storage system. So it's making it a way more reliable than just a simple replication to another instance. Simply replicating from one system to another, and in case of course ransomware attack, we might be damaged by the ransomware, because our system will be connected and mirrored, and those environments will not be separated. But in case of this completely separated use case with S3 bucket, our system make just a simple clones, which will be versioned. And I'm going to show a little bit, maybe even right now, how this connection and having this access will be made. Okay, so we can go to the volumes, and also there is a category cloud volume, and what we can see here is all the volumes which are present on our storage system. Let's say that we are choosing one volume, then we are getting next, and here we can let the system decide what will be the type of snapshot. So system will decide by itself which snapshot should be used, but we can also make complete a full snapshot, which will be clone with setting the relation. So completely, we have three options: snapshot without relation, snapshot with relation but without clone. Second one is complete clone without having relation, so we are cutting the relation with source with the target. And the last one will be complete full snapshot, so clone with having relation with the source volume. Okay, and right now we are creating this complete snapshot. Also visible, all those commands are visible from the GUI perspective. Okay, the task is completed. So that was the one way how to do it, how we can make our snapshots. And right now we may also do it just as simple from category volume. So we have all volumes right here. Right click on each volume, and we are having we see this category cloud volumes. So enable cloud snapshot. Yeah, we are clicking OK because it's kind of warning. And we have enabled snapshot. Now we can manage, create this. Sorry, that was enabling a connection. Now we are creating the complete snapshot. And what we do have here are two completely made snapshots, which are visible from this perspective of of our graphical interface. Okay, so now we are going to see the case how we can restore our snapshot from Amazon Cloud. Let's right click on single volume, which is already in cloud. Then we are clicking this restore, and we are choosing which version, as I have mentioned previously, because we are having this versioning, which version of snapshot we should restore. And let's say that we have chosen one. It's a full snapshot. And there is also possibility of the first thing, restoring directly to the production volume, because it has still this relation between the target and the source. Or we may create a new volume based on on-prem site, on on-prem storage system, which is actually right here chosen. So we are specifying also the name. We are choosing the pool because we may have a couple of pools. We may also choose IA group for caching and for storing it. And we may also check whether the snapshot will be thin provisioned, compressed, or even deduplicated. In case of having this data reduction pool, we will be also able to create the duplicated volume. And the summary, just like it was previously. So the volume size, name, pool, and all the details which were visible previously. Okay, so we have restored our snap, and all of those, we may even see that the snapshot count is 3 already. So the snapshot is not made yet because it needs some time. for having this as online. So right now, for a moment, it's still offline. And the cloud volumes, all the things are here. Okay, so this is how our snapshot looked like. So let me get back to my presentation. Everything is clear about it, about this transparent cloud tiering function? Do we have any questions, maybe?
No, so far it's no questions.
Okay, I think it's pretty easy because we can set everything from the GUI perspective. As you can see, this Spectrum Virtualize GUI is very easy. So everything what we need will be visible already on our Spectrum Virtualize. If something will be not clear, then we also can get to the special redbooks or to special blueprints how to implement this transparent cloud tiering or the hybrid cloud a little bit later. Okay, so let me get back to the presentation. Is the visible presentation?
Yeah. Yes.
Okay, that's great. So transparent cloud steering was the simplest way of implementing this, I would say, hybrid cloud approach. Now let's get to a bit more complex solution, which is building a second site straight in a cloud. So we are not going to only make a snapshots, but we are going also to implement this Spectrum Virtualize in public cloud to have one on-prem site, and the second site will be completely in private cloud or public cloud as we want infrastructure. But before practice, I wanted to list some of capabilities of this Spectrum Virtualize for public cloud, which will be implemented on IBM Cloud. So with software SVC for public cloud, we can deploy almost all features which we used to use in our local data center. So the first advantage, which I can see, is this block space optimization. So we can mention data reduction methods in clouds, like deduplication, compression, thin provisioning, making also those snapshots with relation, without relation, completely clones, etc., to the cloud environment, and use this scalability, which everybody knows of the public cloud. So the second advantage is creating this hybrid cloud environment, and it's extremely easy to do it. I'm going to show you how. So with the Spectrum Virtualize for public cloud and storage inside, which is already included in price of our storage system, we may see and manage everything from one GUI perspective. So after creating a partnership with systems, between the systems, our local storage system will be aware of existing cloud instance of similar system. It could be Spectrum Virtualize on 2, 4, 6, or 8 nodes. So this high availability might be also not only between the sites, but also on a cloud level. Next benefit is this business continuity. So for me, I would say is the most important thing, because we can set synchronous or asynchronous replication, which in IBM is this global or metro mirror in our sites. So creating environment which gonna be not only high available, but also has this disaster recovery feature in case of having asynchronous replication with snapshots. For me, it's a great benefit. And last one, which I listed here. So last but not least, as usual, advantage is a public cloud protection. So I was talking a lot about this ransomware, but we also have to consider this disaster recovery, high availability of our production, which is actually the case of our hybrid cloud implementation. So our volume snapshots clones might be stored in a bucket, just like it was shown, without connection to replicated volumes. So the replication between sites might be set, but also one snapshot, couple of snapshots might be completely separated on another instance of Spectrum Virtualize. Of AWS or IBM Cloud bucket. And this is an overview of the infrastructure. It might look complicated, but actually, look at it, it's extremely logical. So first of all, let's say that we are having this on-prem infrastructure. I know it's a kind of direct connection, but in most cases, we would be using SAN switches or directors. So host is communicating to the flash system by, let's say, the fiber channel, and flash system is presenting volumes to hosts. So just a typical, nothing extremely sophisticated on our infrastructure. And another side is IBM Cloud. This time is IBM Cloud. It might be also AWS. There's no problem. There's also a documentation how to implement it. But coming back to this IBM Cloud, we do have the host after that. Host with applications. After that, we do have this SVC nodes, which are at least 2 nodes for high availability. There is also this Red Hat 7 or 8 or CentOS. And we are implementing this IBM Spectrum Virtualize software because it's understood as a software as a service. And straight after, we do have this cloud volumes, and we are presenting those cloud volumes straight to our hosts, just like it's the same on our on-prem infrastructure. Okay, and now how to do it step by step. First of all, we have to get to this IBM Cloud, the IBM Cloud account, and we have to be looking for Compute Classic, which is this classic computing, which are bare metal servers. And just like it is shown right here, we are clicking on this bare metal servers, and that's the first step. We are getting to the second step, and we are choosing all the details. So we need to implement at least 2 bare metal servers. Of course, we are giving it a name, domain, and there is also a couple things about the billing. I'm not a salesperson. I'm more like a technical engineer. But what I have seen, what I've realized in case of implementing this solution, that this billing is extremely important thing, because as far as I know, we may be looking for some discounts. The longer the period we are going to have our storage on IBM Cloud, the bigger discount we may receive. Okay, but coming to this to technical part, after that we are choosing the location. So I'm sure that the cheapest one is in America, in the USA. But for the most cases, because those are the needs, we have to and government requirements. We have to have our business core, our business systems located in European Union. So in this case, it's Europe and Frankfurt availability zone. Okay, we are configuring servers. So here we do have also a couple of different processors to choose. Everything is made on a bare metal, so no virtual machines are required. Everything is made on the bare metal servers, so on the real hardware. Okay, and this, the third step, we are choosing, first of all, how many drives we do have on our bare metal servers. As you can see, it's pretty cheap. Straight after, we are choosing the storage. So how many volumes we are going to present to our system. And there is the file storage and block volumes. In case of Spectrum Virtualize, we are choosing only block volumes, which will be presented straight to our system. Okay, and the last thing is this network interface. So we do need this 10 gigabyte of public and private network. And let's also consider another architecture. This is a different one on Spectrum Virtualize for public cloud on AWS. It's also possible to implement. I'm not going to show you how, because I chose for this presentation, I chose IBM Cloud, just to differentiate from the previous scenario. And but it's also possible to have all of those services on AWS. Okay, and yeah, this is also a scenario where we are putting, and we are having this transparent cloud tiering, Amazon S3 bucket, which is completely separated from already existing infrastructure right here. Okay, so this is the time when I should show you. I should show you the Spectrum Virtualize for public cloud. And I do also have a video. Okay, so I may already take it away. Miroslav, is everything visible? I mean, my movie.
I see the slide, which is IBM Spectrum Virtualize for public cloud. Okay, now it changed to
okay. That's great.
Screen.
That's great. So we do have also this Storewise V7000. Like it was visible here, we have this implementation of our run system and connecting it to already created, like I showed you on the previous screen, already created infrastructure on IBM Cloud. Okay, so we are logging to the Storewise, just like we did previously for this transparent cloud tiering. And just take a look. There is a Storewise V7000. We are going to make a little overview. What do we have here? So the hosts, we have one already mapped host, which is on-prem server. Right now, let's check some details and modify volume mapping. So it is showing us what do we got here. There is this application volume and data volume with different capacity. So what is already mapped? Which volumes are already mapped to the host, which is present on our system? So we have already created this, like I showed previously. We have created this IBM Spectrum Virtualize for public cloud, and just take a look. All the things here are the same. So we are receiving the same GUI. We don't have to learn anything. That's a great benefit because, as you know, nowadays those systems might be a bit sophisticated, and of course they are complex, but also complicated. But we are receiving the same, so we don't have to learn anything more. Okay, we don't have any volume here, so let's get to the wizard, which allow us to create basic volume. Of course, we are giving some details of the volume because we have to set the connection. Okay, target data volume, capacity savings, thin provisioned. So we overlocate a volume. We have to click create, and after a couple of seconds, yep, operation was completed. So our volume is already online, it's created, and we may start using it. We can also create a second volume, which will be required. Okay, as well, thin provisioned. We cannot map it to host yet because we don't have hosts defined yet. So right now we have to create this replication. I mean, this connection between those sides. So make them visible for each other. because it's required for having this the replication between those. So first of all, we are creating the partnership on SVC in public cloud. We are using IP protocol. We have to put the details of our system, which is on-prem, and on Storewise v7000, which is also on-prem, we have to do the same. So we have to create this partnership between connection to the instance which is already in cloud. Okay, so let's see that we already have this replication between sites. I mean, this partnership between sites, not replication yet. And right now, IBM Spectrum Virtualize for public cloud, yeah, it's visible right here. Type IP version 4, IP address, state fully configured, location remote. Okay, that's great. So let's get back to the v7000, and right now we may already create synchronous or asynchronous replication. So the relationship. And what do we got here? We have three options. First one is metro mirror, synchronous replication. Second is a global mirror, asynchronous replication. And the third one, which I personally understand as the best one, is global mirror with change volumes, because it will allow us to create flash copies of mirrored volumes. So let's see how we are going to configure it. Okay, we are creating the relationship on another system. We are choosing where the auxiliary volume, so this additional volume, is located. First of all, we are choosing the master volume, so the source, and the target, which we have already created. And we are adding this relation between those. After that, we are changing those change volumes. We are making those change volumes, which are kind of flash copies of single mirrored volumes. So we are having source and target, but for each volume, we do have also flash copy of it. Okay, and we are adding it. Previously, we have already made the change volume, and right now we are seeing also the cycling mode and cycle period. So the cycling period is the period between replication is made. It's asynchronous replication, so we don't have to wait for assurance that that our changes were saved on the second volume. We may just easily be writing or reading or changing the data which are present on our volume. Okay, so the volumes are going to be synchronized. We want to start copying now. No, we are not copying yet. We are just creating this relationship without setting in. And our task seems to be completed. Okay, and on our Spectrum Virtualize for public cloud instance, we don't have possibility of starting. Why? Because it seems that we didn't add change volume for this auxiliary volume. So for this additional, we didn't choose already. I mean, we didn't choose yet this second volume. So we have two options. First one is to create additional volume, and the second one is add existing volume. And this is what we are going to do, because we have already created it previously. And yeah, target, change volume, and we are adding it here. The same cycling period. So when it will the period between the synchronization of our volumes. And yes, our task is completed, and now we can set as a start. I'm not going to do it because this status between, the synchronization status will take some time, but it's, as you can see, it's ready to click. So we may just simply start replicating between the sites. And this is what actually looks like. This is what actually we do have. So we have created this architecture of which is built on IBM Cloud, and we understand as this hybrid cloud resilient architecture, which is completely reliable and ready for any disaster which may appear in our data center. Okay, but let me just go back to this Blackbird which we were talking previously. So let's consider once again our infrastructure as a protected against unexpected but very dangerous for our system event, which we call as a black swan event. So in this case, in case of disaster, this disaster recovery, are we protected? I would say yep, we have proved it because of this Spectrum Virtualize for public cloud, because of the relation we have made and asynchronous replication. Yes, we are ready for disaster. For the outage, one of our data center on-prem or on cloud. Second case, in the case of the ransomware, are we protected? Yep, because we are using this transparent cloud tiering, and we are sending our copies of our volumes straight to cloud, to cloud bucket, which is completely separated from our environment. And the third one, in case of losing money, so what's in it for me because of an unavailable system? Okay, if you will not have a viable system, if you will see a great outage or any rolling disaster scenario, then your business will be damaged. So thanks to this Spectrum Virtualize for public cloud, or in case of having this ransomware attack with transparent cloud tiering, yep, we are protected, we are secured. We don't have to worry about our business stop, because we have high available infrastructure, which has also the feature of disaster recovery, which may help us to protect against ransomware attack. Okay, so I think that's all what I was able to show you. Do we have any questions about infrastructure? Maybe some technical questions, maybe some something should be clarified from my side. Miroslav, I don't have, I cannot see any chat. So
yes, it seems that there is no questions.
Okay.
Yeah. So I think that if somebody will have any, they can contact us, and we'll come back to you. So thank you very much.
That's great. That's great. In case of having
presentations.
After presentation, I will be glad to also answer for all of those.
Okay. Tai ką, ačiū labai visiems už dėmesį. Gal šiek tiek tema, kurį šiandien nagrinėjom, nėra tokia kasdieninė ir dėl to galbūt tų klausimų tiek yra mažai, bet jeigu visgi tema, kaip apsaugoti jūsų duomenis, jūsų duomenų centre, kur naudojate IBM duomenų saugyklos, jums yra svarbi, tai kreipkitės, mes galėsim pakonsultuoti jūs ir be abejo galėsim prijungti Bartošą ir jo kolegas, reiškia, parenkant jums tinkamą sprendimą. O šiandien dar kartelį dėkoju uždėmesį ir norėčiau dar paprašyti vieną veiksmą atlikti. Jeigu jums nesunku būtų, užpildykite, prašau, seminaro apklausą tam, kad galėtumėm atsižvelgti jūsų pageidavimus. Ačiū dar kartelį ir geros dienos. Thank you very much, Bartosz, once again, and have a nice day.
Thank you very much also. Thank you. Have a great day also. Bye-bye.
Bye.